Example number one is one function is f of x equal 4x divided by x squared minus 4. And so my recommendation is doing according to the guideline I explained in the last class. By the way, I have here, look, the guideline. 1, 2, 3, 4, 5, 6, and 7 steps. But okay. I try to do without see this part. Okay, the first step always is factorization. You take the original. I am doing the factorization of the polynomial in the top. By the way, it's degree 1. And here is the difference of a square, okay, degree 2. X to 2 plus or minus. This is the factory form. In this moment, I didn't see any factor, okay, it's cancelled out. That is because we have no whole. You know, example, you see yes. Whole. No holes. Okay. But you know very well that the factor gets cancelled, it's a whole. In this case, no, nothing is cancelled. This is the first step. The second is the intercept, is super extremely important point. Y-intercept first, is easy. The formula for finding y-intercept is the value of the function is 0, is 4 times 0, 4 is 0 squared minus 4, times 0 is 0, divided by negative 4, is obviously 0. So in this case, wow, it's a coincidence that the point 0, 0 is both, is x-intercept and y-intercept. Sometimes happen, okay, maybe in the third step, que find the x-intercept, you obtain a new one. Sometimes no. But the origin 0, 0 is y-intercept and also x-intercept. To make sure that we have no more, let's doing the x-intercept. The formula is f of x equals 0. And by the way, it's equivalent to say p of x equals 0. And p of x, remember, is a polynomial on the top. This is p and this is q. You take 4x equals 0. And solve for x divided by 4 both sides. X equals 0, and we come back again to the same. So we have only one point, is both behavior, is x-intercept and y-intercept both. Not always happen in this situation, but in this case happen. You see another more interesting and complicated example, and where you have one y-intercept, but you have several x-intercept, depending on the degree of the top. Okay, in this case, 1 to 6. Okay, number 4 is important, extremely important, is the vertical asymptote. Now the vertical asymptote, the formula for the vertical asymptote, take the polynomial in the bottom Q, this guy, and you enforce it to be 0. Well, in this case, you take, if you want the original, or no, you take the factory form. I prefer the factory form. Is x plus 2, x minus 2 is obvious that the solution of this is negative 2 and positive 2. Okay, so in this important moment, I try to do the sketch in one dimension of our function, at least one dimension. Only one axis, x-axis. Look, I am doing this. This is my famous all real number line. We have infinity positive, we have infinity negative, and you plot The only point we can do that so far is 0, 0. Here, 0. And the two asymptotes is in positive 2 and negative 2. Partition and partition. Actually, we have 1, 2, 3, and 4 intervals. Because you consider the X and Z like a one part of the partition. I don't do the vertical dotted line because it's not vertical asymptote. But in the last step, is number 7, you pick at least, you say, how many additional points, Professor Mark? You pick one here, pick one here, pick one here, pick one here. At least 4. At least 4. So you pick more, much better than you pick 4. This is importance of this sketch. Okay, number 5. Number 5 is the analysis of vertical asymptote or slant. And remember, I put together because it's mutually exclusive. When you have vertical, we have no slant. You have slant, no vertical. Okay, cool. Now you are doing the analysis of degree. Okay, I copy the function one more time. I can see clear the degree of the polynomial in the top is 1, linear. And the degree of the polynomial in the bottom is 2, quadratic. Oh, so I remember the special case of the look, I made a mistake here. This is horizontal, right? I suppose you understand me. Horizontal, vertical, I did. The analysis of the degree we have, let me recall just in case. When a degree is the same, yes, it's a regular case. When a degree of the bottom is bigger than degree of the top, not necessarily 1, degree, greater, in general greater. Suppose 1, 3 or 1, 4 or 1, 5. Entonces, a special case. It's yes, the answer is yes, we have a horizontal asymptote at y equals 0. Es especial. Entonces now y equals 0 is the line, is the horizontal line coincident with the x-axis. So like that. Pam, 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 pam. Pam, 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 pam. Y equals 0. Yeah, I don't do exactly on the x-axis because I don't want to interfere with the point we obtain the interval, but it is the idea. And remember, always you spend 2 seconds to analyze the possibility that this horizontal asymptote can exist. The curve, the graphic we are doing, cross it or not this horizontal. And remember, the key idea is you take the function again, 4x over x squared minus 4, and you enforce it to be equal that value, this thing. Well, remember when you have fraction equal to 0 is because this is equivalent to say 4x equals 0, so I don't care this part because the responsibility to be 0 is similar to this. Look. Oh, those I did before is x equals 0. So basically, wow, unbelievable. Look, this famous point 0, 0 is x and z is also y and z in this example, not always, and is the famous point in which the graphic crossed the horizontal. And this is important point, extremely important to determine always. When you have horizontal, investigate if cross it or not. Okay, just now, number 6. Everyone follow me? No question? Who make a noise? Okay. Remember, this is recording, entonces when you ask me some question, yes, pero noise no. Okay, number 6 is investigate symmetry. To investigate the symmetry, you make a reflection. So you replace x for negative x and let's see what happened. Si stay the same, es even, si es opposite sign is odd, si es no nothing, it's neither. Okay, so you take the original and you replace x for negative x. This is the action is reflection. Negative x squared minus 4, sorry. Ajá, entonces 4 times minus x es obvio que es 4x. And minus x squared is positive. Now, if you want to see more clear, this negative you put in the front. And we compare this new expression and the original is this. And you see, wow, it's identical except que it's opposite sign. So basically, the idea behind this is that when you are doing this reflection, you obtain the same function with the opposite side. Conclusion, this is odd function. Since odd function, I take advantage of this. Because when I compute, I dedicate my time, compute the different point, only taking x positive. Because when you, for example, you take arbitrary x, and the answer, I suppose, is positive here, positive number. When you take negative x, get a reflection, you get negative y, the same y. And you dedicate your time doing the different point here in the positive part, because default I know that the negative part is the same y value, not necessarily compute again, with the opposite side. This is the importance of the symmetry. Okay, so now number 7 is taking additional point. I taking in my paper, let me see, I taking, look, according to this idea, I taking 1, I taking 1, I taking 3, yeah, I taking 4. Uy, noise again. Who making noise? Joseph. I taking, so see you in your paper, you take it arbitrary in each interval. But don't take it 4. Because the symmetry indicate me, because if you compute the positive part, the negative part is opposite sign. And the y value, no? So you take,
So what is the second test?
What is the second test?
Yeah, when is?
In the part 6 symmetry, you say?
No, like when's the second exam, the second test?
Yeah, it's October 17, I guess. Check it out on the syllabus. The syllabus specify clear.
Okay.
Yeah, 17. No, we have time. We need to. So we need this. We need to see another topic because too long, and also we start review, long review in which you cover everything in the chapter 2 from the beginning. So now this is the moment to be ready to take the test. But I checking before I start. Good question. It's October 17. Okay. Okay. Okay, so now you understand the thing I try to explain? I evaluate in 1, I evaluate in 3, I evaluate in 4. And, I can infer the value in -1, the value in -3, and the value in -4 because the symmetry is odd symmetry. Okay, no problem. 1 is substitution. 4 times 1 over 1 squared minus 4. 4 times 1 is 4. 1 squared is 1. Minus 4 is minus 3. Or if you prefer, 4 thirds. What about -1? It's the same value, 4 thirds, but positive. Because the function is odd. That makes sense, guys, or no?
Yes.
Now evaluating 3. 4 times 3 over 3 squared, que es 9 minus 4. This is 12 over 12, no, 16. 4 times, sí, 12, sorry. 9 minus 4, que es 5. It's 12 over 5. If you want to see more clear, you can convert this to decimal approximation. So in this case, it's negative 1.3 repeated, 1.3 to have rough idea. In this case, it's 2.4 positive. One, maybe it's confusing improper fraction, but you divide and that's it. Of course, this is negative 12 over 5. And in 4 is 4 times 3, 4 times 3, no, 4 times 4, because you replace x for 4 over 4 squared minus 4. 4 times 4 is 16. 16 minus 4 is 12. Reducing lowest term is 4 over 3. It's the same value but positive. Okay, entonces la que 1.3, ¿no? Repeat. And f negative 4 is negative. Negative 4 over 3. Now, this is a crucial moment. Put everything together. Let me try by hand and, by curiosity. But we never do it by hand, no? We are using always decimals. After I want to show you. Decimals. Wait a second. This is our picture, the rectangular coordinate. Let me enlarge this. A crucial moment to put everything together. In the first part, we obtain the famous point 0, 0. This is x in a set, this is y in a set, and also this is the point in which the horizontal axis crosses. Sorry, the curve crosses. And number 4, number 4 step, we determine vertical axis. You have two vertical axes. Vertical axis is vertical line. Positive 2 and negative 2. -90 here. And positive 2 and negative 3. Let me try to change a little bit. Okay, to see more clear. So, okay. Wow. And positive 1 vertical axis. Not good. y el negative 2 another vertical acid. Ajá. Now horizontal. Horizontal is horizontal line. Zero degree. And zero. We try to do a little bit here. What is the information that we have so far? Cool. Approximate. What is the information that we have so far? We have vertical asymptote 1, vertical asymptote 2, and horizontal asymptote only 1 is unique. Okay, it's odd function. And the point are 1 comma, this point is the point, 1 comma, this point, sorry. 1 comma, negative 4 over 3. How you plot that? Well, this 1 and x, and the y is negative. It's going down 1 point something, 1.3. So the point is approximately like that. Boom. This is this point. The second point is 3 comma 12, no? It's 2.4. 3.3 comma 3 comma 2.4 3 comma 1 2.4 approximately like that. And this is 4 comma 1.3 again positive, no? In this case positive. So 4 and in red color 1.3 something like that. And you know that the function is odd function. Therefore, this value you put in the other quadrant, in the second and the third quadrant, the opposite side. Remember, negative 1 is 1.3, so it's the same value of this. Same value, but positive. 1.3, approximately here. At the same level of this. It's a coincidence. And negative 3 is negative 2.4. Is negative 3, 1, 2, approximately here. And negative 4 is same of this. Negative 4 is same of this. See? Yeah. You can plot if you want more point, but no. Because you take advantage the vertical. I know that part is positive. Approach it asymptotically, but never touch. Here cross the horizontal asymptote, and let's move on to the negative part and approach it asymptotically. At least I did the graph in the interval between negative 2 and positive 2. After positive 2, well, we have that situation. This is asymptotically approach pero never touch, and this is asymptotically approach pero never touch. Similar idea happen here. Asymptotical touch. Asymptotical. And you see clear now, like a water, that this function is odd function because it's symmetric with respect to the origin. So the same situation that happen here, or happen here, symmetric with respect to the origin. Any question? However, in the real life, we are doing Desmos. Okay, in Desmos, I bring the idea. Look, let me share the screen. Partial function, Desmos. I see something like that. Look, I copy the original. It is the original function. This is the super famous point 0, 0, que es both is x in a z, y in a z, and is the famous point in which the curve, I put the blue color, sorry, cross it the x-axis and cross it the horizontal axis. Okay, entonces I plot different point, I plot the same point, I did by hand, I put separate, it's a order pair, separate by comma, and put the label to illustrate very well this. Now the important thing is, look, it's a 1. 1, the answer is 1.3 repeated, negative 1.3. And negative 1 is positive. Typical idea of the odd function. Everything is okay, guys? Do you understand very well or no?
Yes.
Example 1. Excellent. Remember, 7-step. Factoring x, y in a z, x in a z, vertical asymptote, horizontal or slant, depending on the analysis of the degree. Symmetry and plot different additional points without depending of the problem. This is not one specific quantity, no? Okay. Let's move on to example 2, so you have no question. Example 2 is, wow, too big. Example 2. It's a function that I call g. And the function is 2x squared minus 3x minus 5. Divide. I will see this. I still, okay. Okay. I forgot to share the screen. Whiteboard. Now, you see or not? Joshua. Well, guys, guide me. What should I do now? What is the first step? Number 1. Factor. Very well. You take the trinomial in the top and you multiply. It's 10. And the combination can open the door is 2 and 5. Because 2 times 5 is 10 and 5 minus 2 is 3. So you rewrite 2x squared minus 5. You separate this in 2 and 5 x plus 3x. I take 2, sorry, 2, 2. Here 2. Because if you combine this and this, because they are lighter, we come back. Okay, so this and this are equivalent expressions. But this is nice because it's ready to apply factorization by grouping. Look, this is the this is the red couple, and this is the blue couple. And the red couple, the great common factor I can see is x. We have 2x minus 5. In the blue couple, The great common factor that I see is just 1 because we have nothing in common. 2x minus 5. Now 2x minus 5, I factor one more time. We have x plus 1. Okay, I finished the factorization of the polynomial in the top case. 2x minus 5, x plus 1. Okay, now unfortunately, the polynomial in the bottom is primed. I don't know if you remember very well the sum of a square prime, and the reason is clear because the solution of this quadratic equation is complex or imaginary, right? So in the real field, we cannot factorization this expression. This expression is typical irreducible quadratic expression. A prime we cannot factor. Okay, cool, leave like that. Boom. Now we have no whole again. We have whole only, guys, when you cancel out one, and the factor is cancelled, is gone, is the whole. But in this case, no. Okay, maybe in another example, yeah, but in this example, no. Okay, now I did the step 1, get the factorization. Step 2 is determine the y-intercept. To determine the y-intercept, you need to plug in 0 in the original function. You can plug in it in the original or in the factory form, either way. I don't know why I prefer here, because it's easy to see. In the top you have -5, in the bottom you have +1, so actually it's -5. And the famous point is 0, -5. This is our y-intercept. And the x-intercept, remember, is, what is the formula? The formula is, well, in general is f of x, no, g of x is the name of the function, equal to 0. But specifically, in this example, you take p, and p is this polynomial, this trinomial. But I prefer to take in like that or in factory form. I suppose it's better in factory form because it's super easy to determine the zero of this polynomial or quadratic equation. You take both. You take x minus 5 equals 0. And you take x plus 1 equals 0. You solve it one by one like a linear equation. S2x equals 5 divided by 2 is 2.5. 5 over 2. In fraction, 5 over 2. In decimal, 2.5. It is good convert to decimal because I want to plot. And 5.5 over 2, maybe it's not clear where is the location, how 2.5 is easier, it's in between 2 and 3, and in the middle is 2.5. And the other is negative. Wow, good. So we have two x-intercept. At the point, x-intercept, we have 2. At the point 5 over 2, 0, and -1, 0. So far, everyone follow me? Yes, Jenny. Okay, we did number 1, number 2, and number 3, and now number 4. Number 4 is crucial because it's the vertical asymptote. So the vertical asymptote, well, remember the idea, you take the polynomial q in the denominator and you force it to be 0. But the polynomial q in the denominator in this example is x squared plus 1. And x squared plus 1, I see that the solution of this is complex, or not exactly complex, it's a particular case of complex, it's imaginary, right? Just in case I don't remember, no problem, I try to solve it. Suppose x squared plus 1 equal to 0, x squared equal to -1, and I square root both sides, x is equal plus or minus I. Imaginary, pure imaginary. And remember my recommendation. I explained, I suppose, before. In algebra, when you try to find something and the answer is complex or imaginary, that means that this thing you try to find do not exist. Okay, you normally in mathematics do D and E. It's equivalent to say do not exist. So conclusion, our function, we have no veric acid. No veric acid. This is weird que happen, but happen. Depending on the nature of polynomial in the bottom. Okay, now let's move on to the horizontal Islam. I analyze together because it's mutually exclusive. See, my conclusion is we have horizontal, actually we have no slant. So if we have a slant, we have no horizontal. And this is the degree analysis. I want to copy again our function. 2x squared minus 3x minus 5 divided by x squared plus 1. And we are doing the famous degree analysis. The degree of the polynomial on the top is 2. Pero es because this exponent is 2, no this coefficient. It's a coincidence. And the degree is also 2. And you need to know by memory. If you don't know, I refresh your memory now. When you have same degree, yes. The conclusion is yes. We have. Pero no special, regular. And the special is at y equal the division, this number, and this number gets invisible. It's 2. Cool? And that's it? No. You cannot never forget the analysis of the investigate the our function cross or no this asymptote. So basically the thing I try to, this is the asymptote, and maybe our curve look like that. Oh, and cross. Crossing in only one point after asymptotically. I have no idea, but I try to investigate. Now cross multiplication, as always, is 2x squared minus 3x minus 5 is equal to 2 times x squared plus 1. You distribute it, 2x squared plus 2. My equation so far is 2x squared minus 3x minus 5 equal to x squared plus 2. Wow. At the beginning, I believe, or I suppose, que quadratic equation, but no, it's not quadratic equation. It's not quadratic equation. Okay, now, what should I do? Well, so we have minus 3x is equal to plus 5. It's linear equation. So say minus 3x is equal to 7 divided by negative 3 plus 5. Yes, our point exists. It's the point minus 7 over 3 comma something. This is, you investigate, yes, our function, when you are doing the graph of the our function, this would be super important point, negative 7 over 3. By the way, this is 2.3 repeated. No? Decimal is minus 2.3 repeated. Entonces, the famous point is the point minus 2.3 repeated, comma 2. Because remember, the y is coincident with the y of dust. Cool? Let me try to investigate the symmetry. Here, symmetry. No, o sea, when you have practice, let's do now accuracy. However, when you have practice, let me copy my function again. You can investigate the symmetry too fast because when you create a reflection, look, I create the reflection. You have 2 minus x squared minus 3 times minus x minus 5 over minus x squared plus 1. Es obvio que the part is squared stay positive. However, the part is linear. Gonna affect this, so you have negative, positive, minus 5 over, and the bottom stays the same, x squared plus 1. It's almost similar, but no, because this function have combinations. So suppose that part alone is even, because the exponent is even. This part alone is odd, because the exponent is 1. This part alone, we have no exponent, but it's even, because it's a constant. And the constant look like an even function. And this is even. So the combination, not always, but frequently having, the combination even and odd is neither. So we have no symmetry. Therefore, okay, no problem. The only disadvantage is that I need to evaluate in the positive part and the negative part separately. But how many points? I forgot to make a partition here. I forgot because we have no vertical asymptote. So I lost the glue for this. But the partition is this is any moment we can do that. Because in the next point after the symmetry is the additional point. How many? Well, okay. We have no vertical asymptote. This is my real number line. Okay, what information we have? Well, we have, let me see, we have in the x-axis, we have 2, look at that, 2 x-intercept, and 2.5, suppose this is 0, 1, 2, 3, here, 2.5, positive. I create this, make a partition, we separate this, and negative 1. Cool. And also, we have no vertical asymptote, no, unfortunately, no. Well, okay. However, we have extra point que es minus 2.3, que es negative 2, negative 3, approximately here, and negative 2.3, negative 2.3. So I need to investigate in this interval, in this interval, in this interval, in this interval, you pick at least one arbitrary. I pick here and 1. And you evaluate G and 1. Guys, it's just plugging in. This is arithmetic part. The answer is minus 3. I skip the arithmetic part because it's trivial. And the famous point is the point 1, negative 3. I pick also in 5. Positive 5. This is 3, 4, 5. Here, I pick. You evaluate G and 5. And G and 5, put in the calculator, simplify lowest term is approximately 1.15. the 5, comma 1.15. And also evaluate negative 3. Negative 3 is here. And the answer is 2.2, positive. The negative 3, comma 2.2. But we need one more, right? Let me try. For example, I forgot in my paper, I don't know, one interval here. Maybe negative 2. Okay, let's do it by hand. I pick, this is 2, negative 2 square minus 3 times negative 2 minus 5 divided by negative 2 square plus 1. And negative 2 square 4. 4 times 2 is 8. Double negative become positive is 6 minus 5. Over. This is 4 plus 1 get 5. This is 14 minus 5 get 9 over 5. And 9 over 5 in decimal is 1.8. So we have one extra point. Here's the point, negative 2, comma 1.8. And this is the minimum. If you want to do more accuracy, the plot, why don't you include more? And you see the track of this. So my recommendation is, as always, doing decimals, the graphic part. Then decimals, we have two possibilities to send me your answer, or you go, let me show you. Do you see them? Yes or no? Look, I have here, okay, I have here the graph. The graphic is contained. Okay, the graph is this curve in blue color. I plot in green color 3 point. I don't know why. It's 0, negative 5, que es the y-intercept. 2.5, 0, que es and negative 1, 0, que es x-intercept. Entonces I plot in black color because I suppose que especially in this moment the famous point negative 2.3, 2, que is the famous point in which the curve crossed the horizontal axis. Here I plot only 3 points. I don't know why. Plot only 3 points. Que is negative 3, positive 1, and positive 5. I include extra. Let me try to include. You separate by comma here. Comma, and let me come back to the S negative 2, 1.8. Okay. Suppose open parenthesis negative 2, 1.8. Boom. Look at that. It's this guy. Okay. You want more information, you can select, I don't know, 2. Okay, but you see clear our curve approaches asymptotically to the horizontal axis, but never touch except in this famous point negative 2.3, 2. Here, important point. Don't forget, when you determine horizontal, investigate if possible cross it on. Any question? What part is confused? Come on. Opinion. No? Okay, one more example, number 3 example. This is example 6. Now example 7 in my paper, but in the board is example 3. Okay. Share whiteboard. Example 3. Do you see whiteboard?
Yes.
Example 3 is h is the name of the function. It's rational function. We have polynomial at the top, polynomial at the bottom. This is 2x squared plus 9x plus 4. And at the bottom we have x plus 3. Okay. Step number 1, factor 4. You take the polynomial at the top and try to do your best in the factorization. You multiply, it's 8, and the combination maybe is 8 and 1 because 8 times 1 is 8, and 8 plus 1 is 9. And this is equivalent to say 2x squared, you split in ax and 1x and 4. Now grouping this couple and this couple. The great common factor in the first couple is 2x. X plus 4. Great common factor in the first is nothing get 1. Therefore, x plus 4 comparing 2x plus 1. I did the factorization of the top part. X plus 4, 2x plus 1, and the bottom x plus 3 is just one elementary binomial that is impossible to do anything. This is the original giving. This is the factory form. Okay. Anyone follow me so far?
Yeah.
Now let's do the second point, is the y in a set. Y in a set. The y in a set is on the function h, you plug in 0. Y in a set. The formula is h and 0. H and 0 is obvious in the top. When you plug in 0, that part disappears. Stay only alive 4 and 3. 1.3 repeat. So the famous y in the set is at the point is 0.13 repeat. Okay. And the x in a set, remember, is when the function is 0, que es equivalent to p polynomial at the top only. I ignore the polynomial at the bottom equal to 0. Y I copy in factory form, que es easy to see, x plus 4, 2x plus 1, equal to 0. Therefore, x plus 4 is equal to 0 is equivalent to say x is negative 4. And 2x plus 1 equal to 0 is equivalent to say 2x equal negative 1, divided by 2 both sides, x is negative 1/2. Okay, then we have 2 x in a set. Not always is the same, 2, depending on the problem, no? There are no rules. Depending on the degree, no? Of the polynomial p. Entonces we have 2 points que es negative 4,0 and negative 1/2, 0. This is our x in a set. And this is our y in a set. That one. Y in a set, x in a set. So far, no problema.
Good.
Now, vertical acid. Vertical acid is too easy. So you take the polynomial Q and you enforce it to be 0. Get the polynomial at the bottom. Ooh, x plus 3. This guy. Well, it's a linear equation. It's obvious that x equals minus 3. Okay, minus 3 we have one vertical acid. So in this moment, really, I don't know why I like to make a partitions of the whole real number. Not exactly in this moment. You need to do this because we are using in the last step. However, I like because in that moment you have all information about the partition of the x-axis. For example, I investigate this is 0 in the middle and negative 3. 1, 2, 3, we have our vertical acid. I know that negative 4, we have the x-intercept in half. Negative half is this. We have another. Negative 1 half. I don't care the y-intercept because it's on the y-axis. I need. So basically, I discovered we have 1, 2, 3 partitions. Therefore, we have 4 intervals. This interval, this interval, this interval, and this interval. And you pick at least one in each interval. For example, I don't know, the last moment I picked another, negative 5, and between negative 4 and 3.5, and between negative 4 and negative 3, 3.5, negative 3.5, maybe, and between this and this, maybe negative 2 or negative 1, and after negative 1 half, maybe 1, or maybe 2, or maybe 3. Okay. Okay, so you have at least some idea how it look like that day. Okay, no. I want to investigate the horizontal acid or slant. Okay. I put together, remember, the reason is clear because you have horizontal or slant, no both. And you copy 2x squared plus 9x plus 4 divided by x plus 3. And you are doing the famous degree analysis. Degree of the polynomial at the top is 2, quadratic, degree of the polynomial at the bottom is 1, linear. Okay, so if the degree of the polynomial at the top is bigger than 1, it's a classical situation that we have to slant us. Remember, horizontal is, so you have the same degree, or the degree at the bottom is bigger. In this case, the degree at the top is bigger, but bigger than 1. See, it's bigger than 2, no. For doing the equation for the slant, you need to perform the long division or synthetic division, either way. 2x squared plus 9x plus 4 x plus 3. It's 2x. 2x times x is 2x squared. This is 6x. By subtracting, change the sign. To cancel, and this is 3. Bring down 4. Because I need to continue the division because we cannot stop here because the hypothetical remainder is degree 1 and the divisor is degree 1. No, you stop when the remainder degree is 0. If the degree of the divisor is 1. Entonces, plus 3 again. Multiplication is 3x and 6, no? 6. by subtracting, by 6, no, by 9. 3 times 3 is 9. Time, no plus. Is 9. By subtracting, change the sign. Cancel out that part and negative 5. So I discovered mathematically, algebraically, que the expression 2x squared plus 9x plus 4 divided by x plus 3 is equivalent to that part, que es equation, 2x plus 3 alone, minus remainder que 5, or plus minus 5, entonces 5, over divisor que es x plus 3. I guarantee you 100% que this expression and this expression, when you write using common denominator, is the same. But you see clear now, like water, that part is the slang asset. Slang asset. Okay, slang asset. So the equation for the slang asset is 2x plus 3. Okay. And when we discovered before the vertical, que es negative 3, que es down. Okay. Now I need to investigate if my curve crosses or not. The line. So it's possible. It's weird, but it's possible. For example, you have this line, our curve crossing one point and it's asymptotic. And asymptotic in all direction. This is point. The majority of the scenario do not exist its possibility, but yes, exists, and I need to investigate. How you investigate? Similar to the thing we are doing in the other, in the horizontal. No, you take the original function given at the beginning. And you enforce it to be equal the equation for this line. And you try to do your best in algebra for solving this equation. Another possibility is the person I like. If you, for example, in this equation for sure is identical, is equal. You're subtracting this line, so the original minus this line is equal minus 5 over x plus 3. No? So you want to investigate here, see this and this is the same. I can do that, of course. I want to do. However, one idea that maybe it's good is you take the original function, que es h, subtracting this line asymptote, and you take the other part, and the other part you enforce it to be 0. It's obvious it's impossible, because one fraction que es 0 is because the top part is 0, and you get contradiction, because negative 5 not equal to 0. The answer is no. Okay. Suppose I don't like this, or I don't see very well this. You apply like equal we are doing at the beginning cross multiplication. You multiply this and this. It's 2x squared plus 9x plus 4. And you multiply 2x plus 3 times x plus 3. Okay, let's do it. 2x squared plus 9x plus 4. And you FOIL. 2x squared plus 6x plus 3x plus 9. And we combine like term. This is 2x squared. This is 9x, and this is 9. And you see, wow, this is cancelled also, and you get one thing is completely false. That indicate que the value I try to find is impossible. Same conclusion of this. In algebra, when you set out something and when you try to solve it and you get a contradiction, it's because this equation have no solution. In conclusion, do not exist, do not exist, do not exist this value. So do not exist this point. This point I predict. Look at that. No, no, no. Do not exist. Entonces, we go to the symmetry idea. Symmetry idea, I am doing too fast because I know the shortcut of the even odd. Look, we have here a combination even, odd, even, and odd. Es obvio que es neither. No symmetry. No symmetry. Entonces no symmetry. No problem. And you need to evaluate. I come back here to the one hypothetical point. I pick in my paper. I pick in my paper -5. Because -5 belongs to this interval, -5. And the answer is 4.5. Negative 4.5. The 1 point is -5, comma, -4.5. I pick -2. Oh, it's good because belong to this. Is -6. And the point is -2, comma, -6. I pick in my paper +1. What is this? And the answer is 3 point, well, actually 15/4. 15/4 in decimal is 3.75. And the point is the point 1, comma, 3.75. I don't know why I skipped this point 3.5. You can do that. I suppose can test more did. Now put together. And the decimals recommendedly no piece of paper. No piece of paper. Okay, there you go. Okay, I have. Do you see that one? This is my problem. Look at that. Ish, make it zoom. Make it zoom, make it zoom, make it zoom. O sea, this is my function. Okay, select green color. Look. Do you see this one, right? Yes or no? Answer me.
Yes.
Okay. I don't know why I separate 3 point, 3 point. Because this point I suppose is the y-intercept and x-intercept. That the y-intercept is 0,1.33. This is the y-intercept, the point in which the green curve crosses the y-axis, and the point the curve crossing the x-axis is -1/2, que is this guy. Look, make it zoom, -1/2, and -4. Of course, in the middle, we have the vertical asymptote. Look, vertical asymptote never is crossed, never, illegal. Horizontal or slant, seldom, but it's possible, and you need to investigate. And the slant asymptote is 2x plus 3, this one. And you see how in both directions the curve approaches, but never touch or cross it. In both directions, look at that. In both directions. Cool? You follow me? This is the way I want that you are doing for the test. Or in any problem you have in your life, you need to do that. And remember, you take a screenshot using the application that you need, or that will allow you convert the screen, export, okay, export like a download, like a format PNG, as a format for the pictures. And you select, investigate here, medium, all, and we have here, and the printer, no printer because it's online. You send me the the image, no? Attached to the document. Okay, I have another interesting example, too complicated. But don't worry too much for this because in the test I never put similar to this. But let's try, why not? I come back. One more. Okay, this is example 4. Example 4 is P of x is x cubic plus x squared minus ax minus 11 divided by x squared minus 9. Okay, this example is weird because when you try to do the factory form, at least in the top part, is very, very, very weird. Because, yes, exists the factor, degree 3, exists 2 factors, 3 factors, let's see, but it's weird. Because this cubic equation is very, very complicated. And remember, the scientific division is useful. Maybe when you have whole number, but no decimal. And sometimes when it's irrational, you never get that. That is a reason I don't touch too much this. However, the bottom, yes, is different of the square, xx33, plus or minus. Okay. It's a hard 2 factor. Okay, don't worry too much for this. But you are doing now, for example, the y-intercept. Is P evaluated 0. It's obvious que es negative 11 over 9, over negative 9. Entonces positive 9. Entonces negative 11 over negative 9 is 11 over 9, que en decimal is 1.2. 2 repeated. The point is the point 0, 1.2 repeated. The x-intercept, wow, is too hard because the polynomial on the top is too hard to factorization. Entonces, no conclusion so far. So far, after this. Now, we have the baric acid at x equal 3 and negative 3. Yes or no? Okay, that part. We have a slang because the degree of the top is bigger than 1. And you are doing the famous non-division. It's doing cosine 30 division either way. The way you prefer. X cubed x squared minus x minus 11 x squared minus 9. Okay, so it's x times x squared x cubed minus 9x minus 9x, but not here. No, here. Is put here x times negative 9x. Negative 9x is here. Negative 9x. It's important to keep in mind the column, the degree. And by subtracting, change the sign. Negative loss. You bring down, you bring down, you bring down. This is 0. This is bring down x squared. This is plus x. Okay, now plus 1. And when you multiply, is x squared minus 9. Minus 9 is here. By subtracting, change the sign, negative positive. Let's allow this. This is weird. This is x plus 9. And this is the remainder. Because the degree of the remainder is 1. And the degree of the divisor is 2. Okay, and this is the condition to stop. So basically, my function p of x, is the quotient x plus 1 plus this is 9. Oh, sorry, I make mistake here. Hello. This is not 9, it's 2. It's 2, no, it's negative 2. Look, this is negative 11 plus 9 and negative 2. You're subtracting this by column. This just bring down. So my equation is plus x minus 2 over x squared minus 9. Okay, this is my last linear equation. Y is equal to x plus. Es easy que identification que this line que representa slope es line asymptote. B es 1, so the y-intercept is 1. So this is the y-intercept of the slant asymptote. So the y-intercept of the original function no is different. And okay, and the rest is okay. So you have not too much, but we have information. We have 2 vertical, we have 1 slant, we have y-intercept, no x-intercept, but don't worry too much because this most discover that like an important point. And let me try. I go directly to Desmos. I put together, or at least the information I have available. There's not too much in this example. Desmos. Okay, there you go. This is example 7, and we are doing example I call 8. This example here, wow, look at that. This example bring me something interesting. Okay, we have, remember, we have this line, asymptote is this. We want to flash it, look. But actually my curve is like that. The other is auxiliary construction that we are doing to understand. This is a slant asymptote. And we investigate. But it's relatively easy investigate. I forgot to explain the whiteboard, but the part stay alone is x minus 2. So at x equal to is this point, look, 2, 3. is the point, the famous point in which the curve crosses the slant axis. Now the rest, okay, we have the two vertical, look at that, bam, bam, and 3 and -3. And you select some points and you plug it into the regional, and you plot that, you obtain 1, 2, 3, 4, 5 points. However, I want to illustrate here, okay, if you touch the curve, you see, for example, a gray point, okay, represent important point, okay, is, for example, this point, okay, is the x-intercept negative 1.53 and negative 2.429. This is K is too hard to obtain algebraically, however graphically it's easy. And this is, I forgot, this famous point, que is the y-intercept, remember, was 11/9, okay, is 1.2 repeat. Cool? Do you see the picture?
Yes.
You see the complexity of this problem? But little by little, you approach it, following the strategy, the guideline, 7 steps. And you, little by little, you obtain this. In the test, normally, we have 2 questions about the graphic of the rational function, but not too hard. Not too hard. It's a regular complication, not too hard. And also, I promise, in the review package, we go over again to this, no? Don't remember, see 2 or 3 problems more. Cool?
Yes.
Okay, now I want to take advantage of the time we have, it's not too much, to introduce new topic, the last topic in this chapter. It is about the polynomial and rational inequality. Okay, still in Desmos. Sorry. Still in Desmos. Now, let me go nice this. Yes, cool. Okay, let me try to type in. This is polynomial to make elegant. And rational. Are you familiar with the name of this function? Pero inequality. En plural, inequality, period. Okay. Okay, cool. You highlight the title. Okay, so basically the thing we are studying now is like a non-linear. In the chapter 1, we study inequality a little bit, not too much, but a little bit. Now I study in detail. For example, you have a polynomial function. Suppose que f of x is polynomial, and you have greater than or equal to 0, or less than 0. So we have a strict inequality and non-strict inequality. And the function is polynomial or rational. So we have 4 possibilities, no? Greater than or equal, greater than no equal, less than no equal, less than or equal. And this is polynomial Suppose poly. OR is rational. But there are many ways, guys, to solving this. Some teachers explain different methods. I want to explain my method, guy, like, but no, in the moment I explain my way, I explain the different versions. Okay, we can do that. And see, you don't necessarily you don't like my way. You select the way you prefer. However, the beauty of this is if you are doing well, of course you get the same answer. Suppose example one. Okay, example one is x cubed plus 2x squared minus 3x. Greater than 0. So you see clear like water. Okay, this is polynomial. Right? And in the right hand side, always must be 0. Maybe you don't understand very well why. It's the reason. And some problem is given at the beginning for you, and the right hand side now 0, and you need, this is super important, to start the solution of this kind. You put the function on the right hand side 0. Polynomial or rational? 0. So you need 0 on the right hand side. Maybe you don't understand very well what is the reason, but I want to explain soon, in a few seconds. So what should I do? Well, you take the polynomial in the left hand side, and the left hand side, we have polynomial, and you factorization. So a C greater common factor, I can seek as x. Factor out x, and you have x squared plus 2x minus 3. And now you see a trinomial, and you factorization into binomial, and the combination obviously is 3 and 1, because 3 times 1 is 3, and 3 minus 1 is 2, plus 3 and minus 1. And this is my new inequality after the factorization. I put in the box because this is important. Yes, important is the inequality you using to work, not the original. No. When you are doing the factorization, I put in the box because this is ready to analysis. Okay. So what idea consists the analysis? Well, the analysis is you take the factorization and temporary, you enforce it to be 0. Okay, I know it's a completely different idea, but this helped me to understand the inequality. Okay, this is super easy. You apply the 0 factor property and you determine that the 0 of this equation is 0, is -3, is positive. And this value is super important. This is called critical value. Using the critical value, you are doing one sketch graphically. It's important to say something. The solution of this kind of inequality, that by the way are nonlinear, you have one algebraic part, but you have one graphic part. I don't know, some students forgot to copy in the test the graphic part. So you have algebraic part, factorization, critical value, but now you have a graphic part. I need to see, important for me to see in the test. And using this critical value, you are doing partition. For example, in 0, we have partition. and -3, we have partition. And in +1, we have partition. Therefore, 3 partitions represent 4 intervals. This interval, this interval, this interval, and this interval. And you pick totally, completely arbitrary testing point. Testing points inside each interval. For example, you pick -4, or another student pick -5, -6, -100. It belongs to the first interval, and the answer doesn't affect what value you pick because any value inside the interval have the same behavior. You pick, for example, -1 here, or -2. You pick here, and between 0 and +1 half, 1/2. In between 0 and 1, 1/2, I pick. And after 1, you pick 2, or pick 3, or pick 4. Okay. And this is my testing point. Okay, I use it always blue color. And some teachers say, well, you plugging in, this testing point into the original inequality, and you verify si it's true statement or no, because you analyze the sign. Okay, you analyze the sign. I prefer doing it that way. Look, I create a table. It start raining now. I prefer doing the table. In the table, you put the critical values. CB or TP, testing point. Testing point is -4. Testing point is -1. Testing point is half positive, and testing point is 2. This is the collection of the testing point. And you evaluate not in the original. No. It's easy, evaluate factor by factor. Yeah, either way. Explain this, but either way. Some students, no, I plug in directly, professor, in the region, and that's it. Okay, cool. And you compute the total. Okay, the total is the combination of every factor together, no? And you see. Let me use red color. You plug in -4 in this factor only. Es obvio que when you replace es -4, que entonces es negative. But I don't care the value, I care the sign. Es negative. -4 here is negative. And here, -4 is -4 plus 3. Es -1, es negative. The value is not important. The important is the signs. The important information is the sign. And -4 and -5 is negative. And we have 3 negative, the answer is negative. And you enclose and the 0. This is the important thing that I need. -1 is negative. -1 here is positive. And -1 here is negative. We have 2 negative, the answer is positive. Because when you have even number of negative, you know very well that negative times negative is positive. And positive times positive is positive. So you count how many negative we have in the first row. 1, 2, 3, negative. How many negative you have in the second row? 2. It's even, it's positive. Half is positive. Half is positive. Half is negative. It's a negative. And 2 is positive, and positive because 2 minus 1 is positive, 2 plus 3 is 5, and 2 is 2 is positive. I finish the table. The important thing I need to analyze is this column, que es the total. Y according to my inequality, this is greater than, to be greater than 0 is equivalent to be positive. Okay, this is the important in which this inequality is true is here and here. In other words, In other words, the testing point que pass the test is here, -1, good, and 2, good. So you now again highlight, pero highlight using another color. This interval was good. The testing point -1 pass, and the testing point +2 pass, and the testing point half failed. No, 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 because it was negative, no good. And -4 was negative, no good. Okay, so I am ready to understand and write the final answer. The final answer is, let me see. The final answer is, the final answer of this inequality is, of course, I like so much in the test, can you write the answer in interval notation? Okay, it's from -3, of course, not included the endpoint, because the inequality have no equal. Si es equal, include the endpoint, but it's not equal. So the endpoint do not participate in the game. There's no solution. It's parenthesis -3, comma 0. Okay. The confusing part is some students make a mistake because write the final answer include the testing point. No, the testing point is totally arbitrary value inside the interval, but the interval is extending from -3 to 0. Okay, que es the critical value. Look, tan. And union, because of two pieces, 1 to infinity. Boom, final answer, beautiful final answer. Do you understand very well?
Yes.
Oh, no. Okay. Let's do one more, and that's it. One more, and that's it. Because the next time I want to explain in detail rational and a lot of special and complicated cases. One more example too, and that's it. Because it's raining, the hurricane is coming. I suppose it's not coming, right? What do you think? It's coming or not? I don't think so. Okay, me too. Suppose the example 2 gets a little bit weird. Look at that. Something like that. It's polynomial, but it's different to the first example because we have no right hand side 0. Remember, this is extremely important. So I saw students and even tutor fail because try to solving this. This is super important. You need to write f of x greater than or equal to 0. In this case, I copy greater than because the symbol in this example is greater than. So you need to create 0 in the right hand side. And the reason is clear because it's a level of comparison. Because you suppose in the testing, positive or negative. This is the level of the sea. This is water, and this is air. Okay, so you need to determine, is here or here? This is important level. No arbitrary is given in the problem. No! So you guarantee in the step 0, before start, okay, right hand side must be 0. Cool. Now, I am focusing in the expression in the left, yeah, I apply factorization. Factor completed. The greatest common factor is x squared. You have x squared minus 4. Cool. Now I finish? No, because I see here a difference of a square. Plus or minus. And this is my new inequality. Que es equivalent 100% equivalent algebraically 100% the original. However, nobody understands this. However, everyone understands very well this. Okay? Now we convert temporality to equation because the equation allow me to find the critical value and the solution is 0. The solution is 2 and negative 2. And this is my critical value. It helps me to create the partitions in our famous or real number line. And this is the graphic part I need to see in the solution of the test. Infinity, negative infinity. 0, 2, and negative 2. Because we have 1, 2, 3, and 4 intervals. Entonces, in order to apply testing point, you pick totally arbitrary in each interval. Negative 3 is super good. Negative 1 is super good. Positive 1 good. And positive 3 good. Another student pick another value, no problem. If it belongs to the same interval, it's the same behavior. Here I create my famous table. My famous table, guys, have one first column, okay, TP, testing point. Negative 3, negative 1, positive 1, and positive 3. And we have different factors according to the different columns, sorry, according to the factor that we have. X squared is one factor, x plus 2 is another factor, and x minus 2 is another factor. And you include one extra column que es super important, que es the total sum. Good. And the rest is just plugging in each testing point in any down, and determine the total. So, this is obviously positive because negative 3 squared. You put mentally or in the calculator, minus 3 squared is 9. And 9 is positive. This is negative, and this is negative. 2 negative is positive. I put in the circle because I don't care the rest of the sign. The important sign is the last column. Negative 1 is positive because negative 1 squared is 1. And negative 1 is positive here, and this is negative. 1 negative is negative. And 1 is positive, and 1 is positive, and 1 is negative again. And 3 is positive, and 3 is positive, and 3 is positive. The answer is positive. Okay, not bad. Now, new thing is super important. It's logical. It's logical. It's logical. Okay, this column is always positive because it's a square. So you keep in mind for the future, not now, that when the one factor, okay, we factorization, the exponent is 2, 4, or 6, it's an even number. It's obvious that always this factor is positive. So it's positive to say it's totally useless to use it in the table. But you put in the table only the factor can change the sign. So in the future, not now, because it's the first problem you see that you delete this column. This column is totally irrelevant because it's always positive, and the reason it's always positive is because the exponent of the factor is even. So you take basically, when you are doing the factorization, actually the experimental students are doing one extra step like that. Look. And which you detecting, wow, exponent 2, not good. Because now you rewrite the new inequality like that. X plus 2, x minus 2, greater than or equal to 0. This is my new problem. Gets easier than this. However, it's the same answer because you delete, omit the factor que contain exponent. Cool or no? Do you follow me? I promise next time I want to explain in detail this idea and you see example and you help me to understand because it's a little bit this is no too hard, however require intuition. And intuition sometimes is no, you don't get fast. Okay, no problem, don't worry too much. You accept this, I suppose that you understand a little bit. Now I come back to the original. I come back. I see that the symbol that we use in our inequality is greater than. Okay, greater than. And greater than, again, repetition, not always happen. To be greater than 0 is synonymous to say positive. But the positive is the true. True. And it's a false. So the solution, the interval I highlight is this interval. Okay, is the interval in which negative belong and positive belong to this interval. Remember, the interval is extending from the critical value to another boundary. No? And -1 and +1 fail. Not good. Now I finish one extra detail. Extra, not complicated, but extra detail. Do you see, okay, different to the first example, the second example include greater than or equal to. That means that the solution for this problem is the solution for the inequality included greater than only. I did here, I highlight in green color, but also the solution for the equation belong to our problem. And to include -2, +2 and 0, you put extra, let me see in green color. You put bracket here and bracket here to indicate que incluye -2 and +2 and include 0, que is 1 point isolated in the middle of the dessert, okay, que don't belong to the any, bueno, sí, belong to the, bueno, actually critical value in the middle, but when you write the final answer is paréntesis, negative infinity, comma, -2 bracket to indicate that -2 belong to the solution for this inequality, union, either way you write 0 or you write this interval, either way. I prefer go from left to right. So is 0 is 1 isolate and you put curly bracket. Remember. So you see what is the solution for this equation, professor? Well, the solution set of this equation is 0, -2, +2. You open curly bracket and separate, in this case, 3 solutions by comma. In this case, no, it's only one, but you put a curly bracket because it's no interval, it's just a point. Union, bracket 2, infinity. Final answer. End the story. In this example number 2, intentionally, I introduced 2 new things. The first new thing was what's going on when you have exponent 2. Can you ignore, delete? I want to explain in detail this next time because sometimes you partial delete and sometimes you totally delete. In this scenario that we studied in the example 2, totally delete. Secondly, you introduce new idea in which you have no greater than or less than the traditional inequality, no introduce it, include equal. And when it's equal, the solution for the polynomial, like equation, belong to the solution. Cool? Clear? Everything is clear? Excellent. Beautiful. Fantastic class, guys. And that's it. That's it. I am leaving. I gotta go. Okay, too much for one day. We continue Wednesday. And Wednesday, I am doing a lot of problems of the equality, and maybe start review. Maybe. And we dedicate one entire class to it. We have time. You try to do your best in the homework. And Alex, any question, please send me, but send me a screenshot. No, some student typing, solving this equation. No. You send me the screenshot. I copy your screenshot in my whiteboard. Bang. I solving. I create another screenshot. I send like a picture. I send to you, and everyone understand perfectly and no mistake. Okay, guys. Have a nice, good afternoon. And we see Wednesday. Okay. Bye bye.